signals are calculated. It also tells us if you maintain the particular speed, you can go in all the green lights. Or if you maintain the particular speed, you can have to stop at some red lights. So all the data will be given there. So the background of all this technology is based upon the IoT. So that's what I wanted to discuss this IoT first, and later I just wanted to go into the topic. And let us see what all the sensors are integrated in these cars to adopt this technology. So IoT in transportation, vehicle as an IoT device. When IoT enters the transportation, vehicle becomes IoT device on wheels. Sense and react. They sense, communicate, and react automatically. Smart mobility, safer, faster, and connected roads. So IoT sensors in C-V2X and smart vehicle systems. A comprehensive technical overview of sensors enabling vehicle to everywhere communication and intelligent transport system. So let us see, so what are the sensors we have? We should, what are the sensors needed to adopt this technology in everywhere in the world? So it has to be environment and prescription sensors and positioning and motion sensors and the vehicle status, infrastructure integration. So, which means the modern C-V2X system is integrated with multiple sensors, categorized working on concern to enable safety, efficient, and intelligent vehicle operations. So let us see each sensor by sensor. So what actually it does to the car and improves the safety and improves the technology. So first sensor, environment and prescription sensors, as we have discussed. First is the radar sensor. Second, the camera vision sensors. Third, LiDAR sensors. Fourth, the ultrasonic and infrared sensors. So coming to the radar sensors, it is used for parking assistance, spotting the blind spots. And for example, now we have the Volvo cars. If someone comes before the car, like for example, if we are going on a particular speed, suddenly if someone enters the road, it has the capability of auto braking. So that feature is enabled by the radar sensors. So without this radar sensors and LiDAR sensors, it won't be possible. So majorly the radar sensor used for in the short range, it is used for 0 to 30 meters, used for parking assistance and blind spot detection. And the mid-range sensor 30 to 80 meters for cross traffic alerts, collision warnings. And long range, it is for 80 to 250 meters, adaptive cruise control and emergency braking, as we discussed, like a Volvo cars. And second one, LiDAR sensors. So LiDAR sensors are nothing but high resolution 3D point cloud mapping obstacle detection sensors. So these sensors are used to detect the obstacles. So in the China and US, we have the vehicles which moves autonomously. So without the driver. So the major part is played by the LiDAR sensors only. So it avoids the collisions. It detects the obstacles on the roads and it avoids that obstacles. And it can go smoothly. So the LiDAR sensors are used for the object detection in the vehicles. So all the sensors which I'm talking about, so these all are mandatory sensors to have when we are talking about the driverless cars or else the C-V2X technologies. And coming the next, camera vision. Camera vision, now we have in our Mahindra cars ADAS features and all. So lane marking detection and tracking, traffic signal recognition, whether it's a red, green, or yellow. So traffic light state detection, pedestrian and cyclist identification. If someone when you're going on the road, if any pedestrian or cyclist comes before the car by accidentally, so these vision sensors will have the eye on them and intimate you beforehand itself, or else in some vehicles it will brake automatically. And coming to the ultrasonic sensors and infrared sensor. So ultrasonic sensor, like normally we can find in our normal cars also. When you put the reverse gear, you'll get the beep sounds. So if the object and the car have the long distance, you'll be getting one kind of sound. If the object and the car is in the mid distance, you'll get another kind of a beep sound. If it is very nearby, you will get the continuous beep. So in our normal cars, it's a very common. We have the ultrasonic sensors in even the small cars also. And infrared sensors are used for night vision and thermal imagining for the pedestrian detection or in the low visibility condition. For example, like if the camera fails, so this using these infrared sensors, we can detect like thermally, like whoever, if any pedestrians are walking towards the road or somewhat, using the sensors, we can detect if the camera vision sensor fails. So all the sensors works very collaboratively using the microprocessor boards, and they will give us the efficient output. And let us go on next sensors like pose and sensors. So I think most of our cars now we have the GNSS and GPS modules. So which actually runs with, like, it's called a GPS. And interior measurement unit combines accelerometer, gyroscope, and magnetometer data to track the vehicle orientation, acceleration, and angular velocity, critical for stability and control the trajectory prediction. So which means GPS, for coming to this first one, GNSS and GPS are actually used for exact positioning of our vehicle, where exactly it is. But it doesn't know whether the car face is towards the right or left or towards like front or back. So for that purpose, we use IMU. So which has the gyroscope, magnetometer, and accelerometer to exactly know on which position the vehicle is. For example, if you are going in the perfect way, like in the normal way, it's okay. If when the vehicle is going in the wrong direction, it will also intimate that using the GPS models, using these accelerometer gyroscopes, it will tell us you are going in the wrong directions. So GPS is for positioning the vehicle, and IMU is for exactly what is the face, like where the face is projected, like on to the left or right. So it is for the exact positioning and to pinpoint the location. So these two sensors are used. So, and we have the vehicle condition and status sensors. Now we have some modules which detects the air in the tires. So if the air in the tires are low, immediately you will get the notification on the infotainment system that there is a low pressure in your vehicle. So in the same like that, the throttle positioning sensor and brake pressure sensor, steering angle sensor, engine temperature sensor. So these all sensors you can see. If anything wrong in the sensors, immediately on the dashboard of your steering, you will get the alerts like something is wrong with the brake sensor or steering angle or something like that. If the engine temperature is high, even though you will get the notification over there. And coming to the energy and safety systems, we have battery status sensor, tire pressure, which we have already discussed. Battery status sensor now we are using for EV vehicles, but in normal diesel and petrol cars, it's not mandatory. But in the EVs, it's mandatory. How many kilometers the vehicle can go? What is the status of the battery? And as we discussed, TPMS, the tire pressure monitoring. And next, the fuel level sensor. Fuel level sensor, we can find it in all the vehicles. So how much fuel is left over in our car. And airbag deployment sensor. So airbag deployment sensor in the sense, whenever our vehicle hits any object at particular pressure, and so normal with a small accident, the airbag doesn't open. So it has some calculation at what pressure, at what level of accident, the airbag has to be opened and deployed. And it is connected with the seat belt. When the seat belt is activated, then major cars have this. When the seat belt is activated, only the airbags will be deployed, or else it may not deploy in some cases. And this is about the infrastructure sensors, where traffic camera sensors, inductive loop sensors, and multimeter wave radars. So this is about the infrastructure. So the previous one which we are talking about, this radar, camera, lidar, ultrasonic, GPS, IMU, powertrain control, energy, and safety system. These are the sensors which is inside the car. And this one, the traffic camera sensors, inductive loop sensors, and millimeter wave radar. So these are all the infrastructure based sensors. So as we discussed before, like in other countries, even the car knows when the red color signal, red light, in the traffic, when the red light is going to appear, when the green light is going to appear, which means the car can able to communicate with the infrastructure of the roads. So we generally call it as V2I, vehicle to infrastructure. So in India, I hope in the coming up 3 or 5 years, maybe it may be implemented. I think in total India, we don't have the system here. People are working on it, but we at present we have the automatic speed guns and all, but we don't have this kind of infrastructure at present. They are in the trials. But in other countries where I have seen, they have good infrastructure, all the roads are connected, the vehicle knows everything about the infrastructure. And if any accident happen in a particular place, immediately the vehicle will intimate you that take the another route. But in our regular Google Maps doesn't happen. Sometimes if anyone notifies that map, it will tell you some accident happened, so some slight delay in your route. So one more we have the environmental monitoring infrastructure, which means in case now this is a winter season, so the vehicle also should know where the visibility is properly, we can see through the light or not. So because of that, like we have the sensors of air quality sensors. So PM 2.5, which is a particle sensors, and CO2 is a carbon dioxide sensor, NOx monitoring for emission management and route optimization. For example, I'm going to A to B. So using this air quality sensors and the weather sensors in that particular route, if the route visibility is low, so this type of air quality and all, now we are using it in airlines from very long time, but slowly it is also getting implemented in our road transportation also. So the air quality in the flights, for example, like route A to B, it's very cloudy, or if any rain is going to happen over there, the flight takes another route immediately because it's in the air, it can go anywhere. But it's a road, it's not like that. So it will tell us the what is the best route and the visibility of the particular road to go from A to B very safely. So for that, we have air quality sensors, weather sensors, and smart traffic controllers. So here, if you can see, it will intimate us about weather-based speed recommendations. If the visibility is low, it will ask you to slow down the vehicle. Most probably, if you have heard about the Delhi Express Highway, most of the times, lot of vehicle get accident over there because of the fog. So the people cannot see what's before, like what is happening before. They directly come and crash towards the other vehicles. Because of this low visibility. So if that problem is solved with the sensors, we can avoid that accidents. So because of the low visibility, also a lot of accidents happen in the vehicles. Next, emission-based route suggestions and the predictive maintenance scheduling. So emission-based routing, now I think we cannot, like in Delhi, we have emission, we don't have this, but maybe they can consider into the picture. So some roads we can take where the high emissions are happening. So we have to avoid that route at particular for the particular time, and we have to take another routes. So it's something like if in the particular area, high emission is happening. So the air quality is very low. So calculating that also, we can navigate our vehicle to the another routes, which means to reduce the pollution in this particular area. So let's go to the next. So C-V2X connectivity hardware. So connectivity hardware is nothing but, as we discussed, OBU, onboard unit, which means it will be inside the vehicle. The sensors and all will be inside the vehicle. RSU, roadside unit, which means it is for the infrastructure like lightings, traffic lights, and for the railway gates. So for all these things, we call it as RSU, roadside unit, and which is the sensors which are in our vehicle. So we call it as OBU. And cellular modems, so which may be like 5G, 4G, and DSRC, V2X, PC5 chipset. So whenever you have this OBU and RSU, it is fine if you have OBU and RSU, but they should talk to each other. The connectivity should be there. So that connectivity will happen through this networks only, using the 5G and 4G, or else DSRC. So DSRC is the old technology for the high, like for the 4G and 5G, it's for the higher ranges. So OBU connected to the network, like to talk to each other. So these two things are connected to the network and they exchange the data, and analytics will be coming out. So without, if you have OBU, if you have RSU, if you don't have the network, there's no use. So you should have the connectivity to talk to each other, like OBU and RSU will talk to each other and identify and give us the best results. So V2X, so here like we have dot, what is X? So X is nothing but maybe anything. V2V, V2I, V2N, or V2P, which means one V2V, vehicle to vehicle, direct, safety, messaging, cooperative, and V2I, vehicle to infrastructure, and V2N, vehicle to network, and vehicle to pedestrian, V2P. So these four things have different agendas to move from point A to point B very safely. So first V2V, vehicle to vehicle, which means we should have the connectivity. For example, I'm traveling from Hyderabad to Mumbai. So in between the highway, if something happened on the highway, if the car before us looks at that incident, so immediately it should intimate the other vehicles at the back side. Please be careful. There is an object on the road. So vehicle to vehicle communication happen like this. So it's only the network between vehicle to vehicle. So V2I, vehicle to infrastructure, which means the vehicle know when the red light is going to happen, when the green light is going to glow, and when to go and all. So it is for vehicle to infrastructure communication. So first one is vehicle to vehicle communication, and second one is vehicle to infrastructure communication. So in this, the vehicle can talk to the traffic, talking in the sense like it cannot talk directly, which means the communication, we call it as a talking in the, as part of the IoT, we call it as a talking to each other. So the vehicle will talk to the infrastructure. So whether the lights are green, red, and all, and with the railway gates also, it may be. So communication between vehicle to infrastructure. And next, V2N, vehicle to the network. So vehicle to the network in the sense, for example, an accident happened on the road, but it should be intimated not from vehicle to vehicle, vehicle to infrastructure. So it should be known to the every vehicles which are coming on that particular road. So I'm in, for example, I'm in Madhapur. So some incident happened in the Madhapur. If someone coming from Lakdi Kapul to the Madhapur, so in that case, even the people who are coming towards that line also, they have to know that some incident has happened in the Madhapur location. So which means this communication will happen through the cloud-based network only, because vehicle to vehicle communication doesn't happen because the vehicle to vehicle distance is very long. So in this case, vehicle to network communication will happen. So the vehicle will intimate the cloud network, and from the cloud, whoever is following that route using the Google Maps, the Google Maps will intimate that the route which you are going has some incident happen. So you can take another route, or else you will be slowed down by 10 to 15 minutes until it gets cleared. Kind of notification you will get. And vehicle to pedestrian. Pedestrian sense, if someone comes immediately to the roads and who are walking on the sideway of the roads. So this communication is also there. I will show you the video how V2P happens. So I hope you have understood about V2V, vehicle to vehicle, vehicle to infrastructure, vehicle to the network. And let us see how we can like go through this V2P, vehicle to pedestrian. So these are the 4 things we have in the communication topology. So that's why we call it as C-V2X. X is nothing but these 4 variants, we call it as a X. It may be anything, V2V, V2I, V2N, or V2P. So coming to the sensor integration summary. So we have some kind of layers. So comprehensive sensor suite enabling cooperative intelligent transport system. First layer is perception layer, which means inside that we have radar, LiDAR, cameras, ultrasonic sensor for environment awareness, which means what's happening around the car. Second, localization layer, as we discussed, GNSS and GPS, IMU, wheel speed sensors for positioning and tracking the vehicle exactly on what position the vehicle is. So vehicle stage layer, which means the brake, throttle of steering, TPMS, the battery sensors of status monitoring of the vehicle. Infrastructure layer. So this layer is about not in the car, it is outside the car, which is infrastructure like traffic cameras, loop detectors, environmental sensors like we discussed, air quality sensors and all, and smart controllers. And communication layer, OBU, RSU modeling enabling, OBU, RSU we have seen already, enabling V2V, vehicle to vehicle, V2I, vehicle to infrastructure, V2P, vehicle to pedestrian, and V2N, V2N, vehicle to network, data exchange. So these all are the layers which plays a crucial role in the communication part. So this is the combination of hardware, the software, and the network. So which the technology, the behind is the IoT kind of IoT technology. So let's move to the next. So I'll show you a short video of the IoT technology used for DSRC and C-V2X.
Welcome to IoT Dunia. In this video, we are going to discuss intelligent transport system. Intelligent transport system, since known by all, is an application of technologies such as the advanced senses, PC also involved.
So you can see here, like in this truck, we have LiDAR sensor and radar sensors.
With the electronics and communications. The management strategies, the whole performance to be brought.
So the yellow color ones are the pedestrians.
In an integrated manner, ensuring the safety and efficiency of transportation system.
So when the pedestrian is walking, the vehicle stopped here.
Maneuvering a smart city requires a combination of both the IoT as well as the intelligent transport system. Apart from IoT, there are several other systems too which will allow us to know the details about the overall transportation and its conditions. But they fail due more requirement of memory as well as phone hardware resources. Thereupon bringing the IoT along with the ITS to improve the overall transport system functioning, like an instant message application, for which we use cloud computing, will be used for overall creating an ITS application, which will provide us with the information such as vehicle, traffic, highway, other path details of support to overall safety as well as emergency service and transport management. The data is captured with the intelligent system with which the resources are shared via internet to the computer workstations. Subsequently, the shared resources are all stored in the central data center, which will far away from the location of the workstations. This can be overcome by introducing small servers as client of main cloud server and locate these very near to the smart objects forming Internet of Things. Also, the latency and response from cloud server may not be adequate for real-time analysis and control applications in Internet of Things. In today's scope, IoT brings into ITS a composite interconnected system that allows gathering and deploying information like an instant message. Vehicle is capable of sharing its information using wireless links with other vehicles on road. Also, it can communicate with infrastructures like signal, road sign, bus stop, etc. For more details on intelligent transport system, visit link in description.
So as you have seen, like IoT plays a major role in V2X. And as I said, I will show you the video of V2P, vehicle to pedestrian.
See,
Before that, we'll see exactly what V2X is. So we have seen the technology behind the V2X. And now let us see exactly what V2X mean.
C-V2X technology, the game changer in the automotive industry, connects your vehicle to its surroundings, other vehicles, and beyond, making it the backbone of modern transportation. Picture this. Your car acts as your vigilant ally, alerting you of an oncoming vehicle at a blind intersection before it even comes into view. But the advantages extend beyond collision avoidance. In the event of a traffic incident, digital vehicles not only prevent collisions, but also offer real-time information to surrounding vehicles, enabling a swift response and forming corridors for emergency vehicles to reach their destinations faster and safer. In this digital age, it's not just vehicles that are evolving. Roads are becoming smarter too. By equipping emergency fleets and traffic infrastructure with C-V2X, response times can be shortened by 20%, enabling rescue services to provide prompt assistance. Digital roads empower traffic managers with real-time access to comprehensive information, including weather conditions, congestion levels, and road statuses. Armed with this invaluable data, they can make informed decisions, optimize traffic flow, and proactively respond to incidents. As the V2X ecosystem continues doing users will also, this integration enables smart devices to communicate roads. This integration enables smart devices to communicate with vehicles and infrastructure, deliver
And now it is showing that freeway.
real-time alerts and warnings to both drivers and vulnerable road users.
So here you can see C-V2X completely. So vehicle to vehicle, vehicle to infrastructure, vehicle to network, and vehicle to pedestrian.
By fostering awareness, visibility, and a culture of coexistence, we create a safer environment that respects all mobility modes. To truly serve all road users, trust and data become the driving forces behind the V2X ecosystem. Data exchange fuels the core of this dynamic system, empowering.
So using this V2X, we have many advantages. Like we can give the path to the emergency vehicles, and we can identify the pedestrians, and we can find the parkings where exactly, like parking is the biggest headache in our India. So we can find where the ideal parkings are there, where we can park directly, and we can know the traffic signals. So according to the traffic signals, we can exactly calculate where and what time we are exactly going to reach that location. And we can also identify before itself, like the water, and if any road works are going on, so you can take the another route immediately. So until unless nowadays, like till now, we doesn't know, until unless we go to the particular location, we doesn't know that something is happening over there. So using this technology, we can avoid all those things.
Every road user to play a vital role. By contributing their unique data, they actively participate in creating a safer and more connected environment for all. Leveraging the fast-paced evolution of 5G V2X technology, the future of automotive takes your driving experience to new heights of safety, sustainability, and efficiency. Immerse yourself in seamless connectivity that revolutionizes mobility as we know it.
So I hope you have understood about what exactly C2X means, how it works. So first, this is a dual communication which happens in C-V2X, which is a direct communication and the network communication, as we have already discussed. So direct communication is nothing but car A to car B, which is side by side or else front and back. So for this, direct communication will happen until certain distance up to range of 1 kilometer maximum. We can have direct communication between the vehicles, see car A to car B. Second one, network communication. So car A to car B, for example, if the range is more than a kilometer, so then we can opt for network communication via 5G. So without the network, we cannot use this network communication. But here in the direct communication, without any network, we can directly communicate. So using car, it's like a walkie-talkie. For example, consider a small example. So walkie-talkie doesn't need any kind of network like 5G or 4G. So any kind of network will not be there. So it can communicate directly using the specific channels. So even the direct communication will happen like this from car A to car B. So network communication will only happen in the long range, and that to 5G, 4G, even the 2G is also works if the network is good. So the cars can communicate directly or through mobile towers. That's how they maintain the connection across large distances. So how this V2X help? So V2X help us in avoid accidents, reduce the traffic jams, enable the driverless cars, emergency priority, which means giving the priority to the emergency vehicles like ambulance or school buses, anything. Smart city integration. So in all these factors, V2X helps us. So from last after the COVID, we can see in because that person are taking the vehicles and going because of some transportation issue. So that they are more concerned about the own vehicles. If we help our infrastructure, if we develop our infrastructure using this V2X technology, so even we can save a lot of fuel because the people will be using the local transport sometimes, because other vehicles, if they follow this V2X technology, they know how when to start for the particular location, and they follow the traffic rules, and the traffic will be controlled. And if even we can get driverless cars into the picture, even in India. But its present situation, I don't think so. The driverless cars are ready to move in India. There are some vehicles which are being tested now. I think we still need 3 to 5 years to get it completely. So other countries are opting for it because they are ahead than us in this technology like V2X. They are working out from very long time. So all the vehicles and the infrastructure are connected together. There, this all things work and help us to reduce the traffic and help us to reduce the people and also it helps the people to take the local transport because it also helps us to save the fuel. So it helps us in a lot of ways. So one real-time incident which happened because if there is no communication between the vehicle to vehicle, very recently incident happened in our country, so which is very pathetic. So I'll show you the video of it. So this is the recent bus accident happened on the Hyderabad to Vijayawada highway, maybe if I'm not wrong. So according to this video, the vehicle, there is a person on the vehicle, but according to the real-time scenario, the vehicle is on the road. So vehicle is on the road and the other vehicles have been passing through that way only, but they have not intimated the other vehicles which is coming from behind. So some vehicles have even hitted that bike and the bike have come in between the road. So then this transport, the Kaveri travels. So without knowing it, there is a vehicle on the road. So he crashed into the bike. So this incident happened. So literally the bus caught fire. People, because they are sleeping inside, they doesn't know what's happening. So some of them have lost. You can immediately intimate the next bus which is coming up or the car coming up on the same highway using V2V technology immediately, and V2N technology, like vehicle to network. So the network will be intimated and the buses which are coming in the same road will notify that there is some obstacle on the road. So using this technology, we can save a lot of lives. And unfortunately, this incident happened very recently. So I just wanted to give the real-time example for this. So C-V2X till now we have seen, and we have the topic of DSRC and the comparison of DSRC and V2C. So DSRC is nothing but dedicated short-range communication. So dedicated smart range communication have some limits. So let us see what are the limits of DSRC. Use by seeing some videos, and I'll explain what exactly it is. Yeah. So DSRC is the old system and it is only dedicated for the short range communication. So it doesn't communicate with the network at all. So it communicates on Wi-Fi based IEEE 802.11p standard, which means it doesn't involve any network. It's only the Wi-Fi signal. So using that Wi-Fi signal, the Wi-Fi signal can range up to 1 kilometer. So using this Wi-Fi based technology, the DSRC used to work. And it is only the short range. And as I said, it is having direct link. Car to car communication will only happen. So it cannot communicate with the network. And next, no infrastructure, no cellular tower needed. Limited scalability. So the growth in this DSRC is very limited. So the same DSRC, we were talking about this walkie-talkie, right? In the same scenario, this works. So the range is up to below 1 kilometer only, this can communicate. So till now in India, like we have tested DSRC and V2X, we have started. So I'll show you where the RN is happening in our complete India, at what places it's happening. So DSRC is a one method which the people used to follow before the C-V2X. And there are some limitations for DSRC and there are some limitations for C-V2X also. So let us see. So let us see some video how DSRC works.
The technology relies on a smartphone's GPS and dedicated short-range communications, two-way wireless communications channels specifically designed for automotive use. Typically, both the car and the smartphone broadcast their location and direction of travel. The system alerts both before a potential collision.
So DSRC using this, so using the GPS, it will intimate both the people, where the car and the person who's having the mobile phone. So the car automatically, if this person doesn't look at the vehicle and he still wanted to cross the road, the vehicle will automatically take a brake. It will hit the brake. And if the person look at the mobile phone and see some vehicle is coming, then if he stops, so vehicle don't take a brake, it will go.
The system also functions when the pedestrian is obstructed from the view of the driver, as well as when the car is backing.
So it's not only about the pedestrian is coming, like pedestrian need not to be seen directly from the car. So until this Wi-Fi network, so using GPS, exactly using the positioning, So the vehicle knows that this person is at this pinpoint location, is coming towards the vehicle only. So that's how this DSRC works.
Up. The system on the phone is initially in a standby mode when the pedestrian is indoors or stationary, but automatically activates when the person is moving outdoors.
So let us go to DSRC. I hope you understood. It's a short range communication using the Wi-Fi based network. And coming to the new standards of C-V2X. And next we will go to the difference between the DSRC and C-V2X. So one, see new standards, 4G and 5G networks. Maybe in the future it's also 6G. So uses cellular infrastructure and dual mode. As I have told you before itself, like it works in a dual mode. It works like a DSRC also, and it works as C-V2X also. So it can have direct communication and it can also communicate through the networks. Two communication can happen. It's a dual mode. And superior performance, it's used for long range, faster and more reliable than DSRC. It's a future ready. Supports autonomous systems like automatic vehicles. So this comparison I will let you know in the coming up slides. So C-V2X in the IoT ecosystems, connected vehicle flow. So the flow will be something like this. First, the sensors collect the real-time data, what's happening in the car. ECU, which processes the information which is collected by the sensors, like how much, if the pedestrians are coming, at what distance the pedestrians are, or when it is communicating to infrastructure, when the red light is going to be shown. So all information will be processed in ECU, which is called electrical control unit. It may be the processor based or it may be the controller based. Most probably in C-V2X, people, it's better to use the processor based control unit itself. But when they use the controller based control unit, so it has some limitations. So next, the connectivity. So whenever the sensor is detecting something and electronic control unit is processing that information, what all the data the sensor is giving to this chip, the controller or processor chip. So through the network, it will send to the cloud. So what is happening all around the car at the particular location? Then it will analyze, the cloud will analyze and send the data to the remaining people over the route. So electronic circuit unit, and this electronic circuit unit using the connectivity like 4G, 5G. So it will transmit the data to the cloud. In the cloud, it will be analyzed and stored people who are coming in the particular direction. So let us see about the comparison of DSRC and C-V2X. DSRC I also already discussed, short range, built on IEEE 802.11p Wi-Fi protocols. So let's talk about the advantages of DSRC first. So advantages are it is having the mature technology. So executely tested in the field trials across the Europe, North America, and Japan since early 2000s. It's proven reliability metrics. Network so operates independently, which means the DSRC, as I told you, it doesn't need any network. It works independently. So that is one of the advantages. Deployed systems already implemented in several markets, including the parts of US, Europe, for commercial applications. So this system is already there. It is working from last 2000s. So DSRC. So it is independent of the network. So coming to the limitations, dedicated hardware. It requires special roadside units, onboard equipment, increasing deployment cost and complexity. Because it is vehicle-to-vehicle communication, so there should be a dedicated hardware should be built for the cars. So if there is no hardware dedicated For V2X also we need the hardware, but we need a generic hardware. With the generic infotainment system itself, we can communicate. But so this DSRC needs the dedicated hardware, separate hardware has to be made. And range consents. So range, I said, typically it will work around like below 1000, like 1 kilometer, which is around like 1000 meters. Below that range only, this will work. Maximum it is 800 to 1000. So limited evolution path. So we cannot make much changes in this. We cannot go advanced than this in the DSRC. So understanding V2X, direct communication mode using the network communication mode, unified connectivity. So we have seen direct communication or vehicle to vehicle, communicate with the network, I communicate with the infrastructure also. With a single chip, it can do many things. So C2X advantages, extended range capability. So DSRC is only 1 kilometer. So in C-V2X, it can be unlimited range, but the network should be good. If the network is not good, this C2X doesn't work. The C2X directly converts to DSRC method, like dual mode is there, right? So it converts to a dual mode. It will work on only vehicle to vehicle communication, which is below 1 kilometer range. If the network failure happens, if there is no network in a particular area. So if the network is there, it will work for unlimited ranges. So future proof evolution. So now we are having 5G in India. So it can go up to, I think you have gone through this 6G standards in the previous session. So the 6G can come up in the future coming up days. So from 5G to 6G, 6G to 7G, 7 to 8G, we can move our technology and we can decrease the latency of the data. The delay of the data we can reduce using these technologies. Telecom ecosystem support. So the telecom operators like Airtel, Jio, Idea, Vodafone also has been supporting these devices. So even in the Airtel, we have an Airtel in other, I think Jio, Jio, I don't know. In Airtel, we have M2M SIM cards. We call it as machine to machine SIM cards. Now, SIM cards are especially made for machines, whether for the GPS or this V2X technology or any other technologies. The Airtel has given the separate SIM cards. We call it as machine to machine SIM cards. So even the Airtel and all these people are supporting this new technology, and it is not easy to get that SIM cards. So we have to take the approval from the government using the Saral Sanchar registration, and using that the file has to be submitted to the Airtel, and then Airtel will issue the SIM cards to you. So you have to tell them where exactly you are working with the SIM cards, because M2M SIM cards are very dangerous, because if something wrong, like the bomb blast and all, even those things are happening using the communication only. So even with a single click, so using the communication, the blast and attacks are happening. So the government has made many regulations now, has taken much care in this M2M SIM cards. So next, enhanced future set, which means we can upgrade this technology in the future based upon the networks we have. And coming to the challenges, what challenges we face? So one, network coverage dependency. So as I said, if there is no network, C-V2X doesn't work. Next, technology maturity. So as a new technology standard, C-V2X has fewer large-scale commercial deployment compared to DSRC. Through pilot programs are rapidly expanding globally. It's still taking time for us to move from DSRC to C-V2X. Ecosystem development. Ecosystem development in the sense, like we have already traffic signals and all, we have already having the good infrastructure. And while adopting to this technology, we have to also make the changes in the ecosystem already, which we have. And also government, like we have to check with the government agencies, telecoms, and automotive manufacturers also, whether in their vehicles they are going to implement this technology or not. even that challenge is coming to picture. If the Suzuki is not ready to take up this V2X technology, so even that is a challenge. If the Mahindra is not ready to take this technology, even that is the challenge. So these challenges will be there while adopting for C-V2X things. Yeah, coming to the major comparison. So according to our topic, so the technology, the parameters, DSRC and C-V2X, the technology is IEEE 802.11p Wi-Fi, and here 3G PP, 4G and 5G cellular, short range and long range, communication 300 meters to 800 meters, and in C-V2X, short range plus long range, which is, I said, the dual, it will work as a dual network. It will work as DSRC also, it will work as C-V2X also. So long, and it's unlimited range. Until unless you have the network, it will work unlimitedly. Latency performance, very low. So less than 50 ms. So even if C-V2X also, if we are having a 5G network perfectly, so it is less than 20 ms with the 5G network. For 4G network, it changed. For 2G, it's changed. If there is no network also, there is much latency in C-V2X. Evolution trajectory. So limited roadmap. So in C-V2X, continuous 5G, 6G path. Infrastructure needs dedicated RSU equipment should be needed. And for the infrastructure, for C-V2X, as we discussed, we need the cellular towers to be placed where there is no network. Global deployment. In the globally, the adoption of DSRC is decreased, so only limited adaptability is there present because the people are moving towards the C-V2X. So rapidly expanding worldwide. So C-V2X is rapidly expanding worldwide. So they are stopping this DSRC and they are going towards the C-V2X. And industry support, declining in investment. DSRC, obviously, if the new technology comes, the old technology will be declining. And C-V2X, the strong telecom backing, which means the Airtel, Vodafone, Idea. So these people are backing up very much for C-V2X. As I said, machine to machine SIM cards and all is provided by the Airtel. So these things already we have discussed. So India V2X strategy and deployment. So now let's see how the India is taking up this V2X. So like regulatory framework, the Telecom Regulatory Authorities of India, TRIA, and Department of Telecommunication, which is DOT, have officially recommended allocation of 5.9 gigahertz spectrum band exclusively for CV2X technology, which means the government TRAI and DOT agencies have exclusively given a spectrum band for using this technology. So aligning with India and China and several other Asian markets. So which means the communication, like same communication will happen with these other Asian markets also. And the strategy decision positioning India to leapfrog DSRC deployment, entirely avoiding legacy infrastructure investments. So DSRC, India is not taking up much because it's already the old technology. And coming to the industry adoption, as we discussed, industry adoption means the manufacture of the vehicles. So major India automotive manufacturer, including Maruti Suzuki, Tata Motors, and Mahindra are actively conducting V2C pilot programs and connected vehicle trials. So until unless these manufacturers give the sensors and the electronic circuit unit in their vehicles, so the vehicle cannot communicate with even with DSRC or even with the V2C. So the industry also is making many trials to adopt this technology, and this technology is adopted in other countries long back. So around like eight to like back 10 to 8 years back, this technology is adopted in other countries. So the BYD vehicles and all other vehicles, where the China is manufacturing the vehicles. So vehicles all are having this technology whenever you buy it from the showroom. So there is a regulation where the vehicle should have the mandatory setup. So even the India has to take up this thing as the industry should adopt this technology, and this technology hardware should be given when the vehicle is out from the showroom. So the infrastructure has to be inbuilt, other than we going to the aftermarket and putting the system, keeping the system. So the government has to take this come up with the regulations, so that this all manufacturers come up with the technology inbuilt whenever the vehicle comes out of the showroom. So the key takeaways of decision makers. First one, technology direction. Global momentum strongly favors C-V2X due to superior range. So it has the unlimited range. Second, Indian position. So at present, Indian regulatory bodies and automotives (OEMs) have strategically chosen C-V2X because we are having the 5G infrastructure at present. And implementation timeline, the pilot programming programs are going on. Maybe, as I told you before, it may take more than like 3 to 5 years. So to come to India properly, maybe it will be tested in some places, and then slowly it comes to the other cities, other metro cities also. Strategic recommendation, organization should prioritize VC2X technology investments to ensure compatibility with emerging global standards and long-term infrastructure evolution. So as I said, the spectrum which is allocated for the C-V2X is 5.9 gigahertz. Intelligent transport band is allocated by the government, like TRDA and DOT has been allocated for this technology. So it's simply like just a cars need roads to move, signal needs spectrum to travel, which means the data will be traveled to the spectrum. So the allocation of spectrum is done by the Indian government. So you can see the spectrum allocation. So it's done in 2022. 5875 to 5925 megahertz band reserved for ITS C-V2X communications by India, which is done in 2002, which is mentioned by DOT and TRIA. Smart integration enables smart transport and 5G integration. So these are the regulator bodies we have in India, which is DOT, TRAI, Tech, and ARAI. So Department of Telecommunications, Telecom Regulatory Authority of India. This is one regulatory body for C-V2X. So what should give us the approval. Engineering Center and Automotive Research Association of India. These people has to take this technology forward to get it into India. So already they have been allocated, they have allocated the spectrum, and trial runs are going on. So the clearance have been driverless vehicles in the vehicle, which moves autonomously without the driver.
Changing technology is just to show. So one could for not being able
So if you see at the top, this object.
to distinguish fact from fiction. Take this
So the LiDAR and radar sensors are everywhere on the car, front, back, and the top.
car, for example. Can it drive autonomously or not?
The short answer,
Trivasta's product lead for driving behavior at Waymo.
what you're looking at is the Waymo driver in action. Adapted for a variety of vehicle platforms, it is the most advanced, fully autonomous driving technology in the world today.
What you notice pretty quickly is that these aren't normal. We've been equipped with an elegant array of sensors and software, which allows it to move through the city on its own. That's correct. The Waymo driver is a combination.
You can see the sensors over here. This is radar sensor, this is a camera, this is one more camera. And top we have LiDAR sensor and two cameras. So LiDAR, radar, cameras, as we discussed before in the PPT at the starting. So these all the sensors are used for
Responsible for performing the entire act of driving. That was James Philbin. He's an engineering lead on the perception team at Waymo. I asked him to break down the technology for us a bit more. The Waymo driver handles the task of driving in three basic steps: sense, solve, go. It's the way we describe the highly complex world safely. So, what goes into all that sensing? The sensors that the Waymo driver uses are incredibly powerful, using a combination of LiDAR, camera.
video. Just I hope you understood about the autonomous car, which is having all the sensors. So let us see where the pilot testings are happening in India, across the India. So in coming to the Bengaluru, Karnataka Smart Intersection Innovation. So in Bengaluru, they have been testing V2I, vehicle to infrastructure. So their key focus is more about the traffic signal coordination. So coordinating the vehicle with the traffic signals to reduce the congestion of the vehicles. So in Bengaluru, they are trying V2I, and in Pune, Maharashtra, they are doing R&D on vehicle-to-vehicle collision, like vehicle-to-vehicle communication, and roadside unit development, which is like the warning zones and environment conditions, and multi OEM collaborations, which means the major manufacturers connecting current field tests, accelerating C-V2X standardization and the validations. So collaboration sense that people who are already working on this technology, they have been collaborating with the original manufacturers to do the R&D in the Pune. And next, coming to the Chennai and Tamil Nadu. So there they have been testing on V2V and V2I, which is a track testing, and emergency braking alert. So whenever the pedestrian comes on the we call it as a blind spot. Even that using this technology, it is detected and that will be solved. And Delhi NCR, they're working on advanced 4G and 5G communication, which is V2 like on the V2X technology. Cross industry pilots like telecoms and automotives, which means the Airtel, Vodafone, Jio, and all, and with the manufacturing units like Tata, Mahindra, and the Suzuki. And they're working on the real-time messaging, like broadcasting. If any issue happened in a particular location, they are trying to broadcast on the displays on the roads to take the different way. So on the national highway pilot corridors, for example, if we take the ring road ORRs, so on the ORRs, there are some display boards. So like warning zones and all. So they can also say like control the speed. So we have, whenever we are going very speed, so that the speed limit is only 100. If you open your Google Maps also, in the Google Map it will show. So the speed limit on the vehicle is only on the road is only 100, but you are going 120. So that's how the national highways will be changed in the coming up days. So already we have the cameras, and without the human intervention, the cameras are directly taking the pictures using the ultrasonic sensors. It's capturing the images of the vehicles, and it is directly sending to the police control room. There they are cross verifying it, and we are getting the challans to our vehicles. So the national highways also going to change in the coming up days. So even the Mahindra, I said Mahindra and Mahindra, which are R&D centers, they are working on this. So turning collisions, overtaking assistance, intersection movements, on these safety precautions, these manufacturers are working on it. So telecom operators anyhow, Airtel, Jio, Vodafone, they are ready to support. They have launched M2M SIM cards. I don't think Vodafone and Idea what the future here over in India at present. But Airtel is doing very good, and Jio maybe they are going to release M2M SIM cards very soon. But Airtel they have been doing from last 4 to 5 years. So let's take a glance where all the people are working: Bangalore, Pune, Chennai, Delhi, and the national highways and the Mahindra centers. So these are the places where at present the R&D is going on this technology. So I think we have all covered this. What are the challenges ahead when we are going to start this technology? What are the challenges we are going to face? Which is the spectrum sharing in the sense sharing the allocated spectrum between the operators, telecom operators, and the vehicles. So that spectrum sharing should be shared perfectly. And security and privacy is the main concern. So whenever if all the data is sent to the cloud, if the cloud has some leakage, if any data leak is there from the cloud, again we'll be in a danger. So infrastructure cost is anyways there. Already we have some infrastructure in our India. We have to change that complete infrastructure to adopt this technology. Standardization, certificate and compliance should be needed. So that standardization should be done. Solutions and future scope: 5G and 6G adoption, unified standards, AI-driven safety and collaboration with the industry and the government. So this should be there to find the next solutions and to get the future scope of the project. So role of IT engineers, I'm not going to the future vision of India. So India aims to be connected for safe and smart transportation powered by C-V2X and the IoT. So Indian Express highways will soon talk to the vehicles. I said the talking in the sense the communication. So the express highway will soon talk to the vehicles, saying that you go slow in the particular lane or you take this route to reach the location in the faster and the safer way. And it can also communicate there's a low visibility using these weather sensors. So soon we can see the national Indian express highways to talk to like it they are ready to talk with our vehicles. Even though the Indian express highways are ready to talk to our vehicle should have the capability of communicating with the infrastructure. So coming up days, I hope the manufacturers of vehicles and the express highways will talk to each other in the coming up days. Most probably from now, we can see these things in 3 to 5 years. So thank you for giving me this opportunity. I thank VJT College uh, for giving me the opportunity to take up this session on CV2X on this day. I hope you have understood this session and you enjoyed it. Thank you.
Audience, if you have any queries, you can ask. Or put it in the chat box. Audience, any queries? Sandeep sir?
So here I can see like what is the cost of magnetic loop detector? Maybe it starts from 2500. It increases the range up to like 5000. We have the standard version, but it starts from 2500.
Audience, any other queries?
So I have one more question, like which is better, ML or inductive loop? Which is in the sense like it depends upon the application which we are using. But this inductive loop is completely the hardware part. ML is completely different. So ML is a data analyzing method. So that can take the data from the inductive loops and it will like segregate the data and give it to us. So both are, I think we cannot compare that ML and inductive loop at present. So if, and one more thing, if some sensor failed, then what will affect the automated vehicle? So if some sensor is failed, though, for example, it depends upon the vehicle. So if some sensor is failed in automatic vehicles, like I have shown in the video, it completely takes a side safely and stops. So they'll be having the 2-3 sensors. If one sensor is failed, another sensor will land us safely beside the parking, and it will intimate us there is some failure. And in our normal vehicle, if some sensor is failed, we will be seeing in a dashboard. At present, I think we have not so much updated at present. Some sensors will automatically will get notified for it. In autonomous vehicle, it will safely stop us at the side.
So any other queries?
So one more query, what could be the possibility approach to implement projects related to V2X in a college? Where to start from? So Venkatesh Ramchandra sir, so you can, as I said, like you can start from prototyping this technology using the IoT sensors. So you can use this LiDAR sensor and radar sensors and GPS GSM sensors. You can take 4WD vehicle, the small vehicle, and you can have this all sensors integrated on that, and you can test it using this IoT sensors at present. So we have the IoT sensors available, like ultrasonic sensors available, LiDAR available, GPS systems are available. Take some 4WD vehicle and attach all the sensors on the vehicle. You can test it from the, you can prototype it and test this technology.
Sandeep sir? Hello?
Yeah, thank you, sir. Thank you, Kalyan, sir,
Thank you, sir.
for your thank you for your insightful and thoughtful, provoking presentation. It was truly valuable and useful for all the faculty and research those who are doing. Thank you very much for sir, your presentation. And with this, this session will be concluded, and I'll turn over this time to Odivel sir for further
Kalyan sir,
updates.
thank you sir.
Thank you so much, sir. Thank you for
Thank
giving
you,
me
sir.
the opportunity. Thank you.
So participants, you can join next session by 5:15. You can leave now. You can join session by 5:15. All.